Okay, we are given a nice quadratic function here. It starts in general form. We're going to gather a bunch of information about it, write it in standard form, and then get a nice graph. So the first thing we're going to do on this one is locate, does the graph open up or down? So to figure out if this opens up or down, what we need to do is we need to look at the leading coefficient. In this case, we call that A because it's a quadratic. That corresponds with whatever number is in front here. So we don't see a number in front, so that's automatically a positive 1. So A is positive 1. Because that's positive, that means this graph, this parabola, is going to open up. Next, let's go ahead and find the vertex for this parabola. All right, the highest point and the lowest point on here. That vertex, sometimes we use HK to represent the vertex, x value, y value, to go along with this. Well, the easiest way to do this is first figure out what is h. Now, h is going to be given by the nice formula, negative b over 2a. So, as you can see in our general format, we already said that a was given by 1. We can also say that b corresponds with this negative, as it turns out, 6. So plugging into our formula, we get the negative of negative 6 over 2 times a, we said was 1. All right, a little bit of simplifying down here, and we're going to get h is positive 6 over 2, which works out to be 3. So 3 for an x value. Now we need a y value to go along with this to get our complete vertex. Well, to get that value for k, what we're going to do is just go back to the original function and plug in this x value that we got for our vertex. So that was going to be 1 times 3 squared minus 6 times 3 gets plugged in for that next x plus 9. So I think this works out to be 9 minus 18 plus 9. Which overall works out to be 0 with a little bit of simplifying. So 3, 0 is going to be our vertex. We go ahead and put that on our graph over here. 3, 0 is the vertex. You may notice that corresponds with our x-intercept. We'll talk about that in a second. That also gives us information about the axis of symmetry. All right, so the axis of symmetry is this nice vertical line that always goes right through our vertex and makes a mirror image on either side of it. We typically don't always draw these in when we're drawing our parabola, but just so you get an idea, it's going to go this vertical line directly through our vertex. And because it's a vertical line, it has to be x equals some number. And because it goes through the vertex, it's always x equals whatever the x value is for the vertex. All right, next, let's go ahead and find the y-intercept. Now, because we have a nice function here, finding the y-intercept is always found whenever x equals 0. So we'll just take that x value and evaluate the function when x equals 0. So that means plug in 0 for each of our x's. Okay, 0 minus 0 plus 9 works out to be 9. So we get, great, it doesn't fit on here, a nice y-intercept up here at 9. All right, next, let's think about standard form, kind of moving over there on the right-hand side. Now, we had already said that our a value is 1, so we can plug that in. It's the exact same value for a is over in the general form on the left-hand side. We know that h corresponds with 3, so we can say x minus 3 quantity squared. And then our value for k is 0. So this can simplify a little bit to just be x minus 3 quantity squared. You don't have to put a 1 out in front. You don't have to put a plus 0 at the end, really, either. All right. And let's think about finding x-intercepts. Those always occur when either y is equal to 0 or f of x equals 0, just using slightly different notation. We already said it's going to be at 3, but let's just talk through how we can find that. Where I like to go in this case is I like to use my standard form that we've written over on the right-hand side and plug in 0 for the f of x. So in our case, 0 equals x minus 3 quantity squared. Now to solve this down, because the whole side is squared, we have a nice power equation. Let's go ahead and apply a square root to both sides. All right, the square root of 0 is going to end up being 0. On the right-hand side, because we've composed together something that's squared and a square root, think inverse operations there. We get x minus 3 remaining on the right-hand side. Go ahead and add 3 to both sides. We get x equals 3. is going to be our x-intercept, much like we already said over there when we put it on the graph. All right, so we said it opens up. Opens up kind of means our tails both go up for our end behavior. And we're going to get a lowest point on our graph at the vertex. So on the left-hand side, I can kind of say to myself, well, just roughly sketching this in, it's going to have this sort of look, and it's going to go through that y-intercept. Now, it's going to be a mirror image on the right-hand side of our axis of symmetry. It would be nice if we could maybe locate one additional point over on that side. So you may note on this that this axis of symmetry going across here, we're going to get 1, 2, 3 units to get to that point that we've already located, right? 1, 2, 3 units to the axis of symmetry. I think if we mirror that across and go 1, 2, 3 more units, we'll get an additional point on our graph over here. And I believe that's going to be the point 6, 9. All right, so the rest of our graph kind of has to hit up, match that, and mirror itself over. Now at the bottom, I may have done kind of poor job as far as making this nice and curvy, because it's not going to come to a nice sharp point here at the bottom. It's going to be this nice kind of a U shape going on, what parabolas typically look like. So mine's a little bit sloppy, but we've got some nice key points to go along with this. 3, 0, 0, 9, and 6, 9. So hope this helps out. If you get more than one x-intercept, usually we don't have to try to locate an additional point like we did with the 6, 9. But hope this helps out. Good luck.